Hello everybody and welcome back. Welcome back to part C now of our 2018 Gauss paper. We're just starting part C here with question number 21. The figure consists of 8 identical small parallelograms joined as shown. So we've got 1, 2, 3, 4, 5, 6, 7, 8, sure. These include, including these 8 small parallelograms, how many parallelograms appear in the figure? So they're referring to, well, here's a parallelogram. That's one of the small ones. But of course, we could also do something like this, which is a parallelogram. So we need to count them. And there might be a few ways we could try and approach counting this. We could say, all right, how many parallelograms go over by 1 and up by 1? And there's 8 of those. And we could then say, okay, let's try and find all the ones that go over by 2, up by 1, or over by 3 and up by 1, or up by 2 and then over by 1, and count all of those. And that's going to be a fine approach. I mean, it's the Gauss. It's not meant to be particularly taxing or a sneaky question, although, you will have to put in a little bit of thought. And if you're going to try that, or if you did try that, you might find that you have to be very careful that you haven't missed out a case. Okay, it's very well, it's perfectly fine to try and count all the ones that are 1 by 1s, over 1 and up 1, over 1, up 2. But if you forget something like the over 2 or over 3 and up 2 case, and you don't count those, you can find that you will not have the right answer. And if we take a look at the answers here, all the numbers here are very close together. They're everything from 26 up to 30. Okay, 26, 27, 28, 29, 30. And so if we just miss a couple trying to count them out, we're going to run into a problem. But, it's fine as long as you're systematic and you stick with it, you'll get your answer. Now, I want to approach it a different way. What makes a parallelogram? How do we know what parallelogram we're looking at? And you might think, well, you have to actually, trace out a full parallelogram. Here's one of these up to over 1 parallelograms that I was talking about. But in fact, as soon as I tell you what the bottom left corner is and the top right corner is, that sort of forces your hand. So if I said, here's the bottom left corner and the top right corner, I'm talking about this parallelogram here. Okay? So what I'm going to do is instead, I'm going to draw a copy of this picture. We won't need a whole lot else to do here, but we'll just... There we go. Okay, and so what I'm going to do is I'm just going to go one row at a time, and so I'm going to go up, and in each row I'm going to go over, and I'm going to say, okay, suppose this is my bottom left corner. What are the possible top right corners I could have? Because each one is going to give me a different parallelogram. There's 1, 2, 3, 4, 5, 6, 7, 8 of them. So for this point here, there's 8 parallelograms that have this as the bottom left corner. Notice, for example, that this blue one up here wouldn't work because what's the parallelogram? Well, it'd just be a line. The same reason nothing else here will work either. Okay? So we're just going to get 8 for that one. And now we can continue on. We can say, all right, for the next one, we'll make it green, I guess. How many parallelograms can I have where this is the bottom left corner? Be very careful that we don't switch and say how many parallelograms have this as a corner. We've said, okay, bottom left to top right. We have to stick with it, otherwise we might end up counting this one parallelogram multiple times. Okay? So, well, really anything that's not in the same row or sort of the slanted line, but is further up and to the right will do. And so this one has 6. And we can keep going. These 4 points will make a fine top right corner if this blue dot is our top left corner. And then we can use pink down here. So we'll just get 2. So this one, and then the bigger one. And those are the only ones that have this dot. And then there's going to be nothing for this one here because there's no dots that are further up and to the right from it. Okay, so we just continue on. How about this dot here? Well, we can't use this or this, but we can still use 1, 2, 3, 4 of them up here. Let's clean up my picture. Alright, so there's 4 of them there. How about, we'll get the little cyan here. 1, 2, 3 of them here. And you'll start to notice a pattern in these numbers. They double. Incidentally, if there were another row, there isn't, but if there were, we'd have things like 12 and 9 here. But we don't need those, but we would have them if we kept going. And so now we're starting to think ways to generalize the problem, ways that we could answer it if it were harder, if it were an upper year contest. So we'll get 2 of them here. And of course, once you recognize the pattern, you don't have to, keep drawing all these circles in here or anything like that. As long as you understand, you can just start labeling these lower left corners. And of course, none of the ones up here are going to work out either, because there's nothing to the top and left, or sorry, to the up and right from any of them. These ones at the top, these 5 here, these ones are already, they're the highest you can get. And this one over here, it's far to right. There's nothing further to the right from it, so there is no top right corner if that's the bottom left. So, okay, we just add up 8, 6, 4, 2, and that'll be 20. And then 4, 3, 2, 1, and that'll be another 10, 20, and 10. That's going to be 30. Okay? And that's all there is. And, it's an interesting problem. We can generalize it more. We could add more rows on here. Oops. And we could, keep going down. And it's very interesting, and you could probably figure out the number of parallelograms for anything that was a 2 by 4 is what we've got here. You could probably get a very nice, very general formula. But we're going to stop it there. Our answer is 30. I think that was B. But let's go back and double check. Yeah, there we go. And we know there aren't any more because we've hit the top. There isn't another higher multiple choice answer. So as long as the 30 we found were unique, and they are, then we're good to go. So up next, we're going to continue looking at our Gauss paper. We're going to look at question number 22. I'll see you there.